Now members, we are going to see another question. This one, we have seen when they give you the range. Now I'm also going to give you an example where we have the test and you see the change in signs. So, show that x power 5 minus 3x squared plus 1 has 3 periods. Hence, use the net operation. Find the middle root correct to 2 decimal places. Now, if the tell you correct to 2 decimal places, it means that now, when we are calculating using the linear operation, we shall give our answers to the decimal places and then we can allow the value of rounding off. So now what we do, we say when they don't give you specific values, now you test for values of x near 0. So you come to this 0, then you test the values of x near there. So now when you come to this, you start the values of x around this, we are now using from negative 3 to 3. And you start shooting these ones. Those are the answers that you get there. Now, what happens? You start from here up to here. From here up to here, same sign, so no change. But from here up to here, there is a change in sign from negative to positive. So it means that now, between this and this, there is a root. Now, the corresponding values of x, that's where the roots are going to be. Now, we start also from here up to here, there is a change in sign, meaning there will be our root there. Then from here up to here, also there is a change in the sign, meaning that the root will be between this and this, as you see there. So, their roots in these values from negative 1 to 0 because there is a change in the sign of f of x, as you see. Now that shows that the roots now, for this first root is going to be between negative 1 and 0. The second, between 1 and 2. Between 0 and 1. Then the third, between 1 and 2. As simple as that, as you see there. And now because they are giving us the number of decimal places, now there you can, this is our error, or some people call it the tolerance. The tolerance or the maximum possible error, where n stands in for the number of decimal places. Now the question wants us to get the middle root. Middle root is between 0 and 1. So find the middle root. So the middle root is going to be between this and this. That's why now if I'm starting my initial value, I'm starting with between 0 and 1 to get this x naught. Now, to get my maximum possible error is 0.05. Now, when I get in this is the value of x naught I get. When I substitute in this, I get 0.281. And so this 0.281 is positive. And this one is negative. So meaning I'm coming closer to the value. So meaning now I will move on with this x value when I'm getting the second root. Now, you see that this value is not less than this. That's why you move on to the next value. So when I get this now, when I calculate it there, so my x1 is going to be this. When now I get the error between x1 and x0, I get 0.1, which is not less than 0.05. Which is my tolerance I want. So the error I can tolerate is what I'm getting there. Now, meaning that's not the value of x. I move on. This means the moment the difference is not this. It means that there's still some big distance. And we said, remember we said, when we are dealing with the linear operation, we said the values of x should be close to each other. So now I move on to this. Then I substitute the value of this value so that I get my function. Then I use this and this value in there. Then I also use this. Then when I calculate my x2 is going to be this. There are different ways you can get this linear expression. It's okay. For you use yours, this is mine. I'm not restricting you to use this. Now, when you get the tolerance, when you subtract the error, is 0.013, which is not less than this is greater. We want something less than this. We move on to the next x3. But here, before you move, there's something you have to note. You see that this value is now less than this. So our f of 0.610, remember it gave us negative 0.032. This implies that there is a change in sign from this to this, between these two. So meaning that now, the root, as we said, if there is a change in sign of this function, it means that now, the root is going to exist between now, this x value, and this. Now, when you look at that, you see that now, when I'm going to use this and this, because there is a change in sign from positive, the smallest value is this, from positive to negative, meaning that now, the root I want to get is going to be between these corresponding values of x. That's why now this time I drop this 1. Now I move this. So it's going to be between this and this. Hope you get that. So the idea, I'm still using the same idea here. Now, here now I move on now to this and this because of this idea here. So now, so here this shows that change in sign. Change in sign, implying that the root is between, which implies that the root is between 0.597. Our root is going to be in there, 0.610. Okay, when I put it there, when I get my x3, this is the value I get. When I get it, you see that when I get my tolerance, it's going to be 0.002, which is less than 0.05. And so, because of this, now you may get other values which are giving you a lesser tolerance. But now, that one is, you will do more values. Yet, these are just going to be approximations. That's why I said that my root is going to be approximately to this. Now, this is what I take. And remember, the question said we give two decimal places. When I round off here, it will be now 10, which will give me now, I carry that 1, 5, which will give me a 6. And so our best value you can get is 0.6. So that's it. Always note this idea is when you get a negative, when you get a difference, a change in sign, it means that your number is going to be there. So that's it, members. See you in the next lesson. Now, by the way, I forgot something. If they tell you the list value, now the list value will be this one, because this one is going to be the smallest. The greatest is going to be this one, or the biggest. The middle one is this, that's why we use this. If they want the list, should now use this and this. The greatest is this and this. Okay. See you in the next lesson.